In this review tape, we're going to be going over our work on trigonometry. Now, this is just a quick review. If you find that you need more work on any of these topics, we suggest you go back and look at the original videotapes on trigonometry. Okay, let's start by converting angles from radian measure to degree measure and then back again. Okay, so we'll start problem 1, convert from radian measure into degree measure. And I'll give you several angles measured in radians. Pi over 3, radians, 3/4 pi radians, and minus 7 pi over 12. Okay, now what we have to do is to realize that pi radians is equivalent to 180 degrees, and what we do is to multiply, in each case, by 180 degrees over pi to get an answer in degree measure. Okay, here the pi's cancel. 3 into 180 degrees gives us 60 degrees. So an angle of radian measure pi over 3 is equivalent to an angle 60 degrees. Okay, by the way, over here in 3/4 pi, I can write it as 3/4 times pi like this, or 3 pi over 4. It's the same thing. But still, we're going to multiply by 180 degrees over pi to get the degree measure. Pi's cancel out. 4 into 180. Okay, 4 into, the pi's cancel. 4 into 180 degrees leaves us with 45 degrees. 3 times 45 degrees for a final answer of 135 degrees. And finally, over here, minus 7 pi over 12. We multiply by 180 degrees over pi. Once again, the pi's cancel. Okay, either unit 12 goes, you could say how many 12s in 180, and it would go 15 times, or you could first say divide by 3 and then divide by 4 afterwards. Either way, you get 15 degrees, so minus 7 times 15 degrees, or minus 105 degrees. A positive angle is measured counterclockwise, and negative angles are measured in the clockwise direction. Okay, now let's say we have the opposite problem. I give you an angle in degree measure, and I ask you to go back into radian measure. All we'll have to do in that case is to multiply by pi over 180 degrees instead of 180 degrees over pi. So in example number 2, we want to convert from degree measure into radian measure. A, B, and C. A, we have 90 degrees, B, 210 degrees, and C, minus 45 degrees. And in each case, we're going to be multiplying by pi over 180 degrees. In this case, the degrees will cancel out, and we will get the radian measure of the angle. Okay, so 90 into 180 goes twice, giving us pi over 2 radians. Okay, you can just write pi over 2, or you could say pi over 2 radians. The pi over 2 is sufficient. Here, multiplying by pi over 180 degrees, the degrees cancel out. And you can say, well, say, divide numerator and denominator by 30. 180 divided by 30 gives you 6. 210 divided by 30 gives you 7, for a final answer of 7 pi over 6 radians. And in the last example here, multiplying by pi over 180 degrees, the degrees cancel out. We have minus 45 goes into 184 times, so an answer of minus pi over 4 radians. So the answer's here, minus pi over 4, 7 pi over 6, and pi over 2. Okay, now, in the next example, I would like to compute trig functions of certain basic angles. This is example number 3. We want to compute each of the following. And I'm going to be giving you trig functions of certain basic angles. It is expected that you can figure out all of the answers in problem 3 without actually using a trig table, making use of basic triangles and the graphs of the trig functions. Okay, just want to have you recall what you learned in our trig videotapes. We have two basic triangles which give us trig functions for 30, 45 degrees, and 60 degrees. Okay, in our videotapes we learned how these are originally set up, but if we have a 45, 45, 90 right triangle, and if you think of this as one length, here is 1 unit, and here the length is 1 unit, then the hypotenuse has to be the square root of 2 by the Pythagorean theorem, and from this one can read off any of the trig functions for 45 degrees. If it helps, remember SOHCAHTOA. That is, the sine of an angle is the length of the side opposite the angle over the length of the hypotenuse. The cosine of the angle is the length of the side adjacent to the angle over the hypotenuse. The tangent of the angle is the length of the side opposite over the length of the side adjacent to the angle. And similarly, we have this triangle for a 30, 60 degree, 90 right triangle. The hypotenuse is 2. The side opposite 30 degrees is half of the hypotenuse, or 1, and then this side is found by the Pythagorean theorem to be the square root of 3. Okay, also recall the graphs of y equals sine x and y equals cos x. I've only drawn them from 0 to 2 pi, or from 0 to 360 degrees. Okay, you know that these functions are periodic. They repeat every 360 degrees, or 2 pi radians. Okay, so this would just continue in the same way before and after. Okay, we do know that the sine of an angle runs between -1 and +1. The sine of 0 is 0. The sine of 90 degrees, or pi over 2 radians, is +1, and so on. And here we have the cosine. The cosine of 0 is 1. The cosine of 90 degrees, or pi over 2 radians, is 0. The cosine of pi is -1, and so on. Okay, bearing that in mind, let's compute the following. Cosine pi over 6. Okay, it might be helpful to get the degree measure here so that we know what we're talking about. To find the equivalent of pi over 6 radians, we of course multiply by 180 degrees over pi, and we see that this is the cosine of 30 degrees. Okay, it was cosine of pi over 6. This is what you were given. We multiplied by 180 degrees over pi to see this is equivalent to cosine of 30 degrees. So we go over to our 30, 60, 90 right triangle over here. Cosine is adjacent over hypotenuse. Here is our 30-degree angle. Okay? The side adjacent is this one. Okay? It makes up one of the rays of the angle. Okay? This is the side opposite 30 degrees. This is the side adjacent to 30 degrees. Okay, so adjacent over hypotenuse. That is the square root of 3 over 2. Cosine of 30 degrees, adjacent over hypotenuse, the square root of 3 over 2. And we get it directly. Okay, in problem B, we want the sine of 5 pi over 4 radians. First thing we're going to do is to multiply by 180 degrees over pi to get the equivalent in degrees. The sine of, well, the pi's cancel. 4 goes into 180 45 times. 45 times 5 gives us 225 degrees. Going over that, 4 into 180, 45 times 5, 225 degrees. Okay, now when we're faced with an angle, okay, that is not in the first quadrant, we have to make use of the acute reference angle. Okay, in our videotapes we learned that the reference angle is the smallest angle between, well, first let me start by sketching 225 degrees. This is 90 degrees, 180, this would be 270. 225 would have a terminal side like so. It's 180 plus 45. It's 225 degrees. And of course it's measured in the counterclockwise fashion. Okay, the acute reference angle is the smallest angle between the terminal side of this angle and the nearest part of the x-axis. So here's what I mean by the acute reference angle in this case. The smallest angle between the terminal side of this angle and the nearest part of the x-axis. You don't measure between here and this part of the x-axis. This would be larger. We measure to the nearest part of the x-axis. Or you could say, well, this is in the third quadrant, so we simply subtract 180 degrees from it, and we see that the acute reference angle to use is 45 degrees. We know that the sine of this angle is going to be equal to plus or minus the sine of the corresponding acute reference angle. Now this question mark means I have to determine if it should be plus or minus the sine of 45 degrees. And how do I determine that? I make use of the device. There's a mnemonic for this. You can say all students take calculus, Albany State Teachers College, whatever. The idea is that it tells us which trig functions are positive in which quadrants. The A here stands for all trig functions are positive in the first quadrant. The S stands for sine and its reciprocal are positive in the second quadrant. The T, tangent, and its reciprocal are positive in the third quadrant. The reciprocal of tangent, of course, is cotangent. And the C tells us that cosine and its reciprocal, secant, are positive in the fourth quadrant. Okay, so we say the sine of 225 degrees was in the third quadrant. In the third quadrant, only tangent and cotangent are positive. Therefore, sine must be negative. So this is going to be negative the sine of 45 degrees. And now we say we can go over to our 45, 45, 90 right triangle, figure out the sine of 45 degrees, opposite over hypotenuse, 1 over the square root of 2. So our final answer here is negative 1 over the square root of 2. And you can, if you want, rationalize the denominator by multiplying numerator and denominator by the square root of 2. If you do that, you get, in this case, negative the square root of 2 over 2. The square root of 2 on top, the square root of 2 times the square root of 2 gives us 2. So either of those answers, negative 1 over the square root of 2 or negative the square root of 2 over 2. In part C, we want to work out the tangent of 300 degrees. It's already given to us in the degree measure, and 300 degrees is going to be in the fourth quadrant. 90, 180 to 270, this would be 360. 300 degrees is something around here. The angle like so. The acute reference angle would be this angle in here, measuring from the terminal side of the 300 degree angle to the nearest part of the x-axis. If you think of this as 360 degrees, okay, we see the angle is clearly, the acute reference angle is going to be 60 degrees. So we say that this is equivalent to plus or minus the tangent of 60 degrees. Now, we have to figure out the sine. Well, we say it's the tangent of a fourth quadrant angle, and remembering that only cosine and its reciprocal are positive in the fourth quadrant, tangent must be negative, so we'll get negative the tangent of 60 degrees. And now we go over to our 30, 60, 90 right triangle to find the tangent of 60 degrees. Tangent is opposite over adjacent. Here is 60 degrees. The side opposite has length the square root of 3. The side adjacent has length 1. So the tangent of 60 degrees is the square root of 3 over 1. So we get over here negative the square root of 3 over 1, or simply negative the square root of 3, the tangent of 300 degrees. In part D, we want the sine of minus 135 degrees. Okay, minus 135 degrees means the angle is being measured clockwise instead of counterclockwise. We want to start here and go 135 degrees in the clockwise direction. That will bring us, this is 90, and this is an additional 45. That will bring us like so. This is minus 135 degrees. Now, if we wanted to find the equivalent positive angle here, this would be, if we were to measure clockwise, counterclockwise to that terminal side, we would get 225 degrees, 180 and the extra 45. So instead of working out the sine of minus 135 degrees, we can figure out the sine of 360 degrees minus 135 degrees, or the sine of 225 degrees. Okay, if you're wondering how I got to 225 and you don't see it from the diagram, I've simply subtracted it from 360 degrees. Okay, well, the sine of 225 degrees we already worked out in problem B over here, so we don't have to go through the calculations. Again, the reference angle, of course, was 45 degrees, and it was minus the sine of 45 degrees, since sine in the third quadrant is negative, and we got, using our triangle, negative 1 over the square root of 2. Okay, in E, the tangent of 135 degrees. Here we have 135 degrees. The acute reference angle would be the distance from the terminal side here to the nearest part of the x-axis, and that, of course, is 45 degrees. So it's going to be the tangent of 45 degrees prefixed by the appropriate sign. Now we have to say second quadrant. Well, in the second quadrant, only sine and its reciprocal are positive, so tangent is negative. We'll get negative the tangent of 45 degrees. Negative, now the tangent of 45 degrees will be found from this triangle. It's opposite over adjacent. The tangent of 45 degrees is 1 over 1. Tangent of 45 degrees is 1. So the final answer here is negative 1. Okay. In part F, we're going to be working out the cosine of 5/3 pi. Okay, the first thing we're going to do is change this into degree measure by multiplying by 180 degrees over pi, and that will give us cosine of, the pi's cancel, 3 into 180 goes 60, times 60 times 5 is 300. Cosine of 300 degrees. Once again, the pi's cancel, 3 into 180 goes 60, 60 times 5 for 300 degrees. .300 degrees would be in the fourth quadrant, looks something like this. The acute reference angle would be 60 degrees, the difference between, well, 360 degrees minus 300 is 60 degrees. So it's going to be plus or minus the cosine of 60 degrees. Okay, now, in the fourth quadrant, 300 degrees is in the fourth quadrant, cosine and its reciprocal are positive. Cosine is positive, therefore this will be plus the cosine of 60. And all the other examples somehow that we worked out, they all came out minus. I don't want you to think that it's always you just take minus the trig function of the reference angle. Okay, it just so worked out in many of the examples. Here, for example, we see that it's plus the cosine of the reference angle because it was in the fourth quadrant where cosine is positive. Okay, so we get plus. Now the cosine of 60 degrees, let's go over here. We want 60 degrees adjacent over hypotenuse, 1 over 2. The cosine of 60 degrees is 1/2. Part F here. And the last two parts, G and H. In G, we want cosine of pi, and in H, the sine of minus 90 degrees. Okay, what separates these from the other problems that we've done is that we don't use the triangles on these. These are quadrant angles. Okay, and for the quadrant angles, one method is to use the graph of the trig function. One could also use the definition of the trig functions where you work with a point on the terminal side of the angle. Either way. Okay, here to find the, you could either leave it like this or write it down as cosine of 180 degrees. Regardless, we go over to the picture of the cosine curve, which we have over here. We see the cosine of pi is -1. Okay, on the x-axis we have the angles, and then the y value is the cosine. Okay, so for pi, the cosine is -1. Cosine of pi, cosine of 180 degrees is -1. Now for minus 90 degrees, we realize that, okay, minus 90 degrees, okay, measured, okay, in the clockwise direction is equivalent to 270 degrees here, measured counterclockwise. So it's a sine of 270 degrees. Or if you're working from your graphs of the trig function, sometimes it's more convenient to have it in the radian measure. So we multiply by pi over 180 degrees and see that this is the same as the sine of 3/2 pi. The degrees cancel and we divide top and bottom by 90. So the sine of 270 degrees, start off the sine of minus 90 degrees, which is equivalent to the sine of 270 degrees, the sine of 3/2 pi radians. And looking at the sine chart here, the graph sine of 3/2 pi is -1. Okay, and that brings us to the end of that problem. In problem number 4, we have the following. Given that angle A is in quadrant 2 and sine A equals 2/3, find the other 5 trig functions of angle A. Given that angle A is in quadrant 2 and sine of A is 2/3, find the other 5 trig functions of angle A. Okay. Talking about an angle in the second quadrant. Okay, let's just say it looks something like so. This is angle A. Let's pick a point on the terminal side of angle A. And we can denote that x comma y. R represents the distance of this point from the origin. Then the trig functions of angle A can all be defined in terms of x, y, and r. In particular, the sine of angle A is defined to be y over r. Now, we are given that the sine of angle A is 2/3. And since this can be any point on the terminal side, let's say that y is equal to 2 instead of x, y, and r, let's set it up. Let's set up r equal to 3. And instead of x comma y, y is equal to 2. And let's figure out what x has to be. Make sure you can see this. Okay, we're interested in finding the x. We know y over r should be 2/3, and that seems to work out. All right, the x-coordinate here, well, you could drop a perpendicular to the x-axis, and we could figure out the length of this side of the triangle. We know that the length of this side of the triangle is 2. Since the y-coordinate here is 2, this means this is something over and 2 up. Okay, so let's say we want to figure out what this is. Let's call it x. We can use the Pythagorean theorem. X squared plus 2 squared must be equal to 3 squared. X squared plus 4 equals 9. X squared equals 5. X is plus or minus the square root of 5. Well, the length of this side is obviously the square root of 5. The x-coordinate here must be minus the square root of 5. Let me make it a little bigger to see it. Minus the square root of 5, because we have this point here in the second quadrant, so the x must be negative, the y must be positive. Let's see if this all makes sense. The sine of a is 2/3. It's y over r. We have found that the square root of 5 would be the length here, so that the square root of 5 squared, 5 plus 4 equals 9. The right triangle works out. And we've taken the negative value because it's in the second quadrant, and x is negative here in the second quadrant. Okay, now that we know what x, y, and r are, okay, we're able to write down all of the trig functions of angle A. Cosine of A is by definition x over r. Therefore, it's minus the square root of 5 over 3. X is minus the square root of 5, r is 3. Tangent of A is y over x. Y over x, 2 over square root of 5. Okay, if you want to rationalize the denominator there, okay, we see this is minus 2 over the square root of 5. We can multiply top and bottom by the square root of 5 and get the equivalent minus 2/5 times the square root of 5. The square root of 5 times the square root of 5 gives us 5. So either this answer here or this answer here. So here we had cosine of A, tangent of A. Okay, now the other ones can simply, other trig functions can simply be found using the reciprocal relations. So we have that cosecant of A is 1 over sine A, and secant of A is 1 over cosine A, and cotangent A is 1 over tangent A. Okay, 1 over sine A, 1 over 2/3, or 3/2. One over cosine A, 1 over minus the square root of 5 over 3, which gives us minus 3 over the square root of 5. And if you want to rationalize the denominator, you can multiply top and bottom by the square root of 5 and get minus 3/5 the square root of 5. And finally, 1 over tangent A, 1 over 2 over the negative square root of 5 would be minus the square root of 5 over 2. Okay, now in problem number 5, we have the following. If the sine of 25 degrees is 0.423, find, in part A, the cosine of 245 degrees, and in B, the cosine of 295 degrees. All right. We wanted to find the cosine of 245 degrees. Okay, even though it's not a basic angle, we would proceed the same way that we did in an earlier problem. We would look to see what quadrant the angle is in. 245 degrees would be someplace between 180 and 270, so it's somewhere in here. We would get the reference angle by subtracting 180 degrees from that. And we see that this is plus or minus the cosine of the acute reference angle, which is 245 minus 180, or 65 degrees. And we say, well, this is a third quadrant angle, and cosine is negative in the third quadrant. Only tangent and its reciprocal are positive. So we have negative the cosine of 65 degrees. Okay, and at this point, since it's not one of our basic angles, we could look it up in a table, but we were given some information here. We were told the sine of 25 degrees. Well, you could say, well, how does the sine of 25 relate to the cosine of 65? We do know that the cosine of 65 degrees, the cosine of an angle is equal to the sine of its complement. The cosine of 65 degrees is equal to the sine of its complement. Two angles are complementary if they add up to 90 degrees. So the cosine of 60 degrees is the sine of 90 degrees minus 65 degrees. It's the sine of 25 degrees. So bearing that in mind, we do not need a table, since we were given this particular value. The